How's everyone doing? Ooh, that. Come on, you go louder than that. How's everyone doing? Right. Well, before I start, I do want to give some props. Let's give it up for the Mad Hats conference team. Nick, Marina, Kuzma, Alexa, everyone who's put this on. This is like my second year coming, and it gets better and better. I don't know about you, but that magic tea definitely put me on a trip. So I could definitely confirm that. No, I'm just having fun. But no, seriously, the spread is so nice outside, and it's really great to be here. So I have the pleasure of interviewing Stefano. I'm going to read his bio just so we're all on the same page, because this is a very, very impressive individual. And we're going to have a really deep dive talk on where LLMs are going, what he's doing differently with Inception, and of course, where he sees the future, because we can't not talk about the future at something like Mad Hats. So Stefano Ermon is a prominent AI researcher, entrepreneur, and he was a professor of computer science at Stanford University. Best known, this is why you all want to definitely take a seat here. He's definitely known for pioneering work in generative AI. And right now, he's the co-founder of Inception Labs, also known as Inception AI. So let's get started. So Stefano, talk to us about your journey from academia. Like, we talked offline about you had a lab, you were doing this cutting edge work. Why did you want to go and co-found Inception AI and do that?
Yeah, excited to be here. So I'm Stefano. I've been a researcher in AI, studying generative models for a long time, like over a decade. I started building generative models before it was cool. I still remember, it was hard to publish papers on generative models. It was hard to get funding for research on generative models. People did not understand why you would want to train a machine learning model that can create images or text. So those were different times. I've been lucky to be working at the frontier of how these models are built and served. My group at Stanford is mostly famous for having invented diffusion models, which is kind of like the main approach that is used today to generate images, video, music. If you've used Stable Diffusion or Midjourney or Sora, they're all based on diffusion models. That work, initially started out focusing on images and video. But since 2019, I've been thinking about how to extend that kind of approach to text and code generation. Initially, things didn't work. But then in 2024, a couple of years ago, we had a breakthrough in my lab. And we figured out a way to basically train diffusion-based language models that were competitive with the kind of approach that everybody else was taking, which is the standard GPT-style autoregressive model, where you generate left to right, one token at a time. And so we published a paper showing that we could train a GPT-2-sized model, so something with less than 1 billion parameters, which was kind of like the largest model we could train given the compute that we had access to in the lab. But it was very exciting because for the first time, we were able to match the quality of an autoregressive model using a diffusion-based approach. And these diffusion-based LLMs were like 10x faster than the traditional autoregressive model. And the reason that is possible is because existing models like the Claude models or GPT models or the Gemini models, they are all autoregressive. And what that means is that they generate, you ask a question and they will generate an answer left to right, one token at a time. Instead, the diffusion models that we're training at Inception are essentially more parallel. So they work like a traditional diffusion model for images or video, where you start with noise and then you gradually refine it until you get a crisp answer, a crisp image at the end. And because these models are able to modify all the tokens, all the pixels in the image, they are significantly faster than the traditional autoregressive models. And so that's the kind of technology that we've been building at Inception. We've trained after the research at Stanford, we started a company called Inception to scale up and train commercial scale diffusion-based language models. And we've been successful in training large scale models that are competitive in quality with some of the best speed-optimized models from Frontier Labs, but they are significantly faster. We're able to get to over 1,000 tokens per second with these diffusion-based LLMs. And so you can kind of get the speeds that you would get using AI inference chips on Cerebras, Grok. We're able to serve our models on GPUs, and so they are also significantly more cost efficient compared to traditional autoregressive models.
So along those lines, you mentioned you have the secret sauce. You said that you can do something better and faster.
Yeah.
And how was this developed? Was this developed post Stanford? Like, is this why you needed to do Inception and not stay at Stanford? Walk us through that journey.
Yeah, so the core of the research started out at Stanford. We had to figure out a lot of new mathematics, a lot of new science to figure out how to extend a diffusion-based model to that was originally created for images and video to more discrete kind of settings like text and code. So a lot of the initial algorithmic idea, a lot of the math was developed at Stanford. Then when we started scaling, we started trying to figure out how to train bigger models, how to make them more efficient. We had to keep inventing new things. We had to kind of eventually change a lot. And so at Inception, we had to develop new methods for training the models, for serving the models. We had to build our own inference stack. And so there's a lot of IP that was developed at the company, but a lot of the core initial ideas came from my lab at Stanford.
Walk us through kind of, because you talked to me offline, that, 2024 is when you had to go all in. Like, what's it like now at this moment with all this attention on LLMs and inference and like, how is it different than when you started it?
It's it's getting more and more exciting by every day. I think we were early in the sense that we realized that the trend was shifting from training towards inference. Everyone was focused on trying to find the most efficient solution for training the largest model in the most efficient way possible. And so if you think about historically, the big shift happened in 2017 when people figured out that if you transition from a recursive neural network, an RNN, to a transformer-based model, you can get much better scaling when you train large language models. Why? Because a transformer-based model can process many tokens at the same time. It's more parallel, and so the scaling laws are significantly better. Now, the shift was starting to happen towards spending more and more resources, more and more compute for inference, serving these models to more and more people, enabling more and more applications, agents. And so it became obvious that we needed something more scalable for inference, not for training. And so we had to think about a way to make the model more efficient at inference time. And the way you make things more efficient is always through parallelism. The bitter lesson is that the more parallel solution is the one that is going to win. And so we had to figure out a way to move away from the traditional autoregressive generation where you generate one token at a time and move towards a paradigm where you are able to modify, to output many tokens at the same time with the neural network. And that's what diffusion models can do.
Okay. I want to ask a question to the crowd. Is anyone here a early stage startup founder? Raise your hand, and I have a very specific reason why I'm asking. Okay, we have a couple here. Anyone here in the process of raising money? Raise your hand. Okay. Wow, you guys are all funded by DVC, I guess. There's like not many hands there. I was kidding. Question for you on building the company. I want to talk about that for a sec. Like, what was the transition like from going from the research world to building a company? And the second question, if you can answer it, is how do you stay focused with all the attention and all the things happening? Like, walk us through that, please.
Yeah, so it was there was definitely some learnings switching from the lab to the company, but fundamentally still a lot of the work, especially in the first few years of the company, was still mostly R&D, kind of like figuring out how to train the models, how to make them as efficient as possible. So the work was not significantly different from not too different from the one I was used to be doing at Stanford. So the focus was heavy on research And so the day-to-day was not too different from the lab at Stanford. I think what changed is the scale, the fact that we finally had access to a lot of compute, a lot of engineering resources, the ability to buy data. And so that's really the thing that changed. And that's why I started the company. If we wanted to compete with the labs, the big labs, and Google and all the other players, we needed more resources to really scale up the size of the model and all the kind of like dirty work that you need to do to actually get good performance in practice. And so that's why I had to raise venture capital to get the resources to really scale up and demonstrate and go from a research idea to a prototype to a product, which is where we are right now.
Okay. And I have one more question for you. And if anyone has a question specifically for Stefano, we're gonna do it right after this. Where do you see now the world of frontier labs and LLMs? Now that you've been in it for so long, I mean, you were a pioneer to a certain degree with what you did at Stanford, to the work you've been doing the last few years. Like, what's your prediction as we're entering 2027?
Yeah, what we're seeing is that inference time scaling is becoming more and more important. Agents and the ability of having LLMs that can reason, that can think through many possible solutions, that can revise their solutions, that can interact with tools, with environments to get better and ultimately achieve more and more complex tasks. That's where things are going. Eventually, they might even get towards self-improvement, where maybe the LLMs are actually able to improve themselves. It's all part of the same pattern. It's all about kind of like shifting from training towards the inference. And that's why it's such an exciting time for Inception, because we have a solution that it's more scalable at inference time, which is the axis that is going to matter more and more as we deploy these models to solve more and more complex tasks and in more applications. And just people are using AI more and more to solve all kinds of different things.
Okay. Does anyone have any questions for Stefano? Yes, you, sir.
Yeah, so our model is still, like the neural network under the hood is still a transformer. So although it's trained differently, it's used differently at inference time, but it's still based on attention. And so we still have like the kind of quadratic scaling that you would have in a traditional autoregressive model. So it's not better, it's not worse. The models that we have in production, they have about 130,000 tokens of context length maximum. And so it's not the largest, but there is no fundamental bottleneck. We can get to essentially as large of a context as we want. Yeah, the main value proposition right now is speed and cost. Those are the two axes where we dominate autoregressive models. And that's the value proposition. A lot of our customers, when you think about an LLM, you always care about three things. You care about quality, you care about speed, and you care about cost. And you see that different LLMs, they kind of like land differently across this spectrum, right? And depending on the application, you might care more about quality, you might care about speed, you might care about cost. There is a fundamental trade-off that cannot be avoided if you're using an autoregressive model. And so if you want the highest possible quality, you need a very large model that is going to be slow, it's going to be expensive. If you want a fast model, then you typically need something smaller, which is not going to be as accurate as maybe what you need. With a diffusion-based LLM, we're shifting that Pareto frontier. And so what that means is that for the same, you can pick whatever latency is okay for your application, and then you can get higher quality compared to what's possible with an autoregressive model. Or for the same speed, you can reduce costs. So you're basically able to achieve different kinds of trade-offs, which might make sense depending on the application that you're thinking about and depending on what you're optimizing for.
Before we go, could you tell people where to find you, how they want to use your product?
Yeah, please visit our website, inceptionlabs.ai. We have an API platform where you can use our models today. It's all OpenAI-compatible, so it's very easy to try out our models. It's just like 1 or 2 lines of code that you need to change to swap out traditional autoregressive LLMs with a diffusion-based one. You're going to get high-quality results, very fast answers. Our models are very cost-efficient. It's like 25 cents per million tokens input, 75 cents per million tokens output. So it's very economical. and it's really, really fast. So if you're working on real-time agents, voice agents, coding agents, where you really care about interactivity and latency, give it a try. It's very easy to take them for a spin. We have a pretty generous kind of like free tokens package when you sign up, and so please give it a try.
All right, thank you very much. Good up for Stefano. Thank you.